All right, so I'm going to replace my f of x with a y. So it's like y equals 6 to the x. And the reason I replaced it with a y is because an inverse is when you swap your input and output, or in other words, I'm going to swap x's and y's. So now I've got x equals instead of y equals, and 6 to the y. All right, so I swap my x and y's, and then I've got to solve for y. But small problem, that y is up in the exponent. All right, so Giovanni, do you remember how to solve for the exponent?
No.
Let's look back. Here we go. These are our notes from yesterday. So what I did was rewrite like this logarithm right here. I rewrote it as exponential format. Or I can go backwards. I can take my exponential format and rewrite it as a logarithm. I can go back and forth, which the whole point of a logarithm is to solve for the exponent, which is why we're going to use that to solve for this exponent, y.
So would we just put long y on the other side?
The y, the exponent is on the other side. That's true. But I still need to deal with the base of the logarithm and then the argument. So what's the base on this one?
Would it be 6?
Yes, the base of my exponential was a 6, so the base of my logarithm is a 6. Very good. And then what's the argument?
Would it be y?
The y, actually the exponent was on the other side of the equation. So the x, yeah, the x is my argument. Log base 6 of x equals y. All right, so we solved for y. And the only thing I'm going to do after that is, because they started out with an f of x, I'm going to call this function my f inverse of x. So I kind of replaced the y with the f inverse. It's a different notation. It's still log base 6 of x though. That hasn't changed. All right, so I started with the plain f of x and I ended up with my f inverse of x. All right, so in this one, I started out with an exponential function and I ended up with a logarithmic function. You can also go backwards. Let's start with a logarithm and we're probably going to end up with an exponential. Okay, so first things first, what I did in blue, I'm going to have to do this again. Instead of the function notation, I'm going to call it a y. And then natural log of, instead of an x plus 3, I'm going to go y plus 3. Alrighty, so then I'm going to go to the green stuff here. This is where I had to swap my x and y's. So it says x equals instead of y equals. Natural log of x plus 3. Oh, wait. Wrong. Sorry. I kind of jumped ahead here. That was supposed to be an x plus 3 there. Now I replace it. There we go. I'm going to replace that x with a y plus 3. There we go. That's better. All right, so I replaced my x's with y's and I replaced my y's with x's. Now I need to solve for that y. But small problem, that y, that's in my logarithm. Okay, if I had a square root of y plus 3, if I had it like this, could I subtract 3 over to the other side? No, I couldn't. Why not, Josh? Oh, I'd have to square it first. I got to get rid of the square root. And then I can do what was under my square root. But I had to get rid of the square root first. Same deal with my logarithm. I got to get rid of this logarithm before I mess with the stuff that is in my logarithm, in the argument here. I can't mess with that y plus 3 quite yet. So I'm going to rewrite it. Nice, Bailey. Nice, Laura. I'm going to rewrite it as exponential form. So Landon, I'm going to reach out to you. Do you know what the base is on this one? I can't see the little, like this one was a base 6, but I can't see what the base is on this one. Can you tell what it is? Landon, are you there, hon? Not hearing from Landon. Okay. So then Sadie, I'm gonna ask Sadie, are you there? Uh-oh. All right. So what about this then? Laura, are you there? Oh, Sadie, I did call on you. Okay. So Laura, hold tight. I'll come to you in a sec. Sadie, I'm looking at the base on this natural log. What is the base on every natural log, really? Or I'll help you out and scroll up here to some previous notes. So do you see in the box there, what is the base of that ln, that natural log? What's the base on it? Sadie, you there? All right, no response.
Sadie's there.
All right, Lauren, I'm gonna reach out to you then. Lauren, what is the base? Okay, thanks, Laura. Log base e of x. Okay, so natural log is a log base e, which means in this case, if I'm going to, oh, you're good, Laura, we're good. So I'm gonna treat this like a base of e where I rewrite it in exponential form. I need an exponential with a base of e. So Laura, what I was gonna ask you though is rewriting it in exponential form. We got the base, what's the exponent on that base? Yes, it was whatever's on the other side of the equation, which was the x. That is true. So it's like e to the x equals, all right, and then what does e to the x equal? Laura, what does this e to the x equal? Yeah.
Okay, so I think e to the x equals the base, right? ln.
We actually already used, this was a base e, so we already used the base.
Equals y plus 3.
Nice, so you did the whole thing, the whole argument, nice. Equals the entire y plus 3, good. Okay, so what I was doing over here is I was trying to solve for y, and as soon as I changed it on problem 21, as soon as I put it in logarithmic form, I actually had the y all by itself. This one, I just put it in exponential form, but the y is not all by itself right now. So I need to subtract 3 on both sides. So you get my e to the x minus 3 equals the y. Okay, so I got the y alone. So Samantha, this is, the e was my base on any natural log. So I was kind of doing what we did up here, where I take whatever the base is and I make it the base on my exponential. So since I had log base e, I had to have e raised to an exponent on my exponential format. Does that kind of clarify it all? All right, cool. So yeah, I was rewriting it, not necessarily canceling anything, I was just rewriting it. And then I'm gonna do what I had in black here. So I don't want it to be a y, I want an inverse function. So usually your inverse notation, it kind of looks like this exponent of -1. It's not an exponent though, it's just a, like I said, like a notation of inverse. So I started with a g function. So Bailey, if I started with a g, how can I write the inverse of that in place of the y? Nice, super close. So yeah, I do want it raised to a -1. That is true. The only thing I would adjust is it didn't, see how number 1, it started out, or sorry, 21, it started out with f of x, and 22 is starting out with a g of x. So I think I'm gonna do very similar to what you just did. I'm just gonna do a g to the -1 of x. So g inverse instead of an f inverse. Does that make any sense? All right, cool. So yeah, whatever they named it, it's really just the name of it. And I did the inverse of that original type function. Yeah, Kaylin, what's your question?
When in big ideas it says y equals,
Uh-huh.
you put the e to the x times b.
Yeah, so yeah, in big ideas, they usually already have this part taken care of. They'll put, yeah, y equals a blank, or they'll put, you know, your f inverse of x equals, and then you have to fill in the blank, right? But I think they usually take care of this kind of notation. There might be a couple you have to fill it in, but for the most part, I think this is what it looks like. Does that answer your question? Okay. All right, so in fact, 23 here, I don't have to do the blue step. The blue step on both of these was replacing my function notation with a y. And on number 23, it already has a y. So I don't really have to replace that with anything. What I do need though, all right, so let's be clear on this. I got my natural log all by itself on number 22. All by itself as in there was nothing on the outside of it. There was nothing added or subtracted, multiplied, divided, nothing on the outside of that natural log. Here, this common log, it does have something on the outside. It's got that 2 on the outside. So I really need to take care of that first. I'm going to, let's see, I'm going to swap my x and y. X equals 2 times log of y. And before I turn it into exponential format, I've got to get the log by itself. I want that 2 out of there. So I'm going to divide by 2 on both sides. All right, so I've got x over 2 equals log of y. Okay, so now this is just a log. There's nothing added or subtracted on the outside, nothing multiplied, divided on the outside, no negatives on the outside, nothing on the outside of it. Got the log by itself. Now I can do what we did over here where I turned it into exponential form. All right, so Tyler, what is the base on this if I didn't write it? It'll be what? Oh, my natural log was a log base e. So let's look at these guys. My natural log was log base e. That is true. Yes, this one over here. If I didn't write the base, if it's just plain log, it's because it's log base 10. Nice. So I'm considering this base of 10. They don't have to write it, but if I know the base is a 10, that'll help me turn it into exponential. So Tyler, finish it off. How do I turn it into exponential format? My inverse function, I'm basically going to rewrite this function in exponential form. 10 to the, like this one was e right here, raised to the x that was on the other side. So you're doing 10 raised to, what's on the other side? X over 2. Yeah, so that x over 2 is the exponent. Equals, all right, what does it equal now? Y, nice. Which was kind of our whole goal. We were trying to solve for the y. In fact, I don't even have like on 22, I had to get rid of the +3 on my y. I don't have anything else going on with the y. The y is by itself. Awesome. So I'm just going to change the notation. This one started out as a y. So I'm going to do y inverse there for this 10 to the x over 2. Again, this is not an exponent. It's a notation for an inverse function. This is my y inverse. All right, what kind of questions do we have before I have you guys try number 24? Yeah. You guys online? You guys have any questions?
Why do we make it inverse?
Nice. Okay, so first of all, it says find the inverse function. That's for one. But also the definition is when I swap my input and output. So because I did change the x's and y's, because I did that, then it is defined as an inverse function. Does that kind of clarify it all?
Okay, so like when we had like the y at the beginning, like that means like we haven't done like the inverse yet, so we do it at like the end.
Yes, exactly. They haven't swapped the x and y yet. This is a plain y. I had swapped the x and y, so I called it my y inverse.
Okay.
All right, cool. And then Bailey, so the x, so where were you trying to put the x? Good question. Because this one was an f of x, this one was a g of x. So I put, f inverse of x, g inverse of x. This one just said straight up y though. It didn't say y of x. So that's why I just did my y inverse, like my y to the -1 here. Does that make any sense? All right, cool. All right, these are good questions, you guys. So I'm gonna have you guys work on 24. Find the inverse for number 24. And then I'll start calling people, see where we got. I got rid of that too on the outside, stuff in purple. I got rid of that. got 2 on the outside of my logarithm. You don't have a 2, but you have other stuff on the outside of your logarithm. There you go. Oh, there you go. Got knocked it out. Yeah, hello. Totally. Yeah, so take that base, raise it to an exponent. We're super close. The only thing I would say is, I wouldn't divide by that, subtract by over. Because it's not 5 times, right? This is 5 minus.
Oh.
So I gotta subtract 5 both sides. You know how to do it before? So what's the base? The base is what's raised to the exponent. There's an equation, yeah. So this. I'll try to make the argument just a little bit. I'll put parentheses on the long systems, like the whole thing's argument. All right, you're good, Chase. So Chase, let me know what you got stuck on. You're good, Alana. You guys are not the only ones. Thanks for telling me. I'm not sure where we got stuck. Okay, so let's start it, and then you tell me where you got stuck here. So I'm gonna start with swapping my X and Y. Okay, are there any questions on that first step? No question left. Okay, so we're okay with the first step. Next up, I need to solve for this Y. Oh, nice, Chase. Yeah, I do need to subtract 5 on both sides. Because it's like the stuff that I put in purple on this one, I was trying to get my log by itself. That's why I divided the 2 over. I didn't want anything on the outside of my log. And currently, this stuff has got to go. That is on the outside of my log. So, yeah, so totally, Chase, you subtracted 5 on both sides. Nice. X minus 5 equals, I didn't get rid of the negative though. I still have a, put this in the green actually. I still have a negative on my logarithm. On the outside, right? I want everything on the outside gone. So I think I'm gonna divide by a -1 on both sides. And kind of turn this into a positive log base 7 of 4y. I got a -x and a +5. So again, that stuff in the purple there, I was trying to get rid of anything on the outside of my logarithm. So Alani, how are you doing on this? You good, Chase? Are you okay with this? Yeah, you guys in here? Are we okay so far? All right, so far, you guys at home? Thanks, Thomas. All right, all right. Thanks, Jack, Crystal. Nice, thanks, guys, Sam, Laura. All right, okay, so at this point, here's where I was on this previous problem. I got my logarithm alone, nothing on the outside of it anymore. So that's why I went from that logarithm into the exponential format. So that's what I'm gonna do from here. I had a log base 10, so I made my exponential with a base of 10. Well, on this one, I've got a log base 7. I'm gonna have an exponential with a base of 7. Raised to, this is where I usually see the mistakes, what the exponent is. The whole point of a logarithm is to solve for the exponent. So whatever's on the other side of the equal sign from my logarithm is my exponent. Like the entire -x plus 5, that whole thing is my exponent. And then this should equal the argument. Again, package deal here, that whole thing, the whole 4y is what this has to equal. Okay. I think this is probably where the most people were getting stuck, going from logarithm to exponential format. Any questions? Nice, Alani. Seriously, we're all good on this?
So far.
So far, so good? All right, thanks, Jack. Really, we're doing all right? Okay, so I'm trying to get like this one where I had actually all of these, I had the y by itself. As of right now, I have a 4y, so I'm gonna divide by 4 on both sides. All right, I got the y by itself. Messy, I've got 7 raised to this negative x plus 5, and then all over a 4. Okay, but I did solve for the y. And my original problem said y equals. This is not a plain y. Those two don't equal the same thing. In fact, I swapped my x's and y's, so I have to call this a y inverse. I'm going to rewrite this guy as my y inverse. Okay. It's got to be inverse because I found it by swapping x's and y's. It's kind of my definition of an inverse. All right, what kind of questions do we have on number 24 here?
Is that the natural log when you moved the 7 and changed the negative x plus 5 into the exponent?
So a natural log is defined by this ln right here. It's a log base e. I had a log base 7, so this was not a natural log.
Okay.
This was me like rewriting my logarithmic form into exponential form.
Okay.
All right, anything else? So you guys can do this on your homework. You can find inverse functions on your homework. All right. We have done this, like I said, for other types of functions, but these are like inverse functions, exponential functions, so you have to use the logarithms. We also have graphed inverse functions before, so just a refresher here. Inverse functions have to reflect over this line y equals x. You like swap your x's and y's, right? So it's a reflection over the line y equals x. So the blue ones we've seen before. These blue ones, this is my exponential growth. That was when my base was greater than 1. It was like 2 to the x, 3 to the x, something bigger than 1 was raised to the x. That gave me this exponential growth. And whenever I have that exponential growth, the inverse is going to look like this logarithm right here. Log with a base that b is greater than 1. So like log base 2 of x, log base 3 of x, log base 500 of x, whatever. As long as that base is greater than 1. All right, and then my other graph over here, this is when my base was between 0 and 1. So again, you guys have done the exponentials before. This would be exponential decay, like it's getting smaller and smaller. And then its inverse is this logarithmic equation. Log base b, but again, the b is between 0 and 1. So it'd be like log base 1/2 of x, log base 0.7 of x, whatever is between 0 and 1. Okay, so let's look at kind of the key features here. The domain of your f of x is the range of your g of x, which, think about this for a sec. If I swap x's and y's, the x's are all the domain and the range are all the y's. So if I swapped my x's and y's, I pretty much swapped my domain and range on the graph. So that's kind of going on with both of those. The domain of your f of x function, f of x like the logarithm, is the range of the g of x function, like your exponential. It's like you swapped your domain and range. So both of those are true if the range, the range of your f of x is the domain of the g of x. Again, you swapped your domain and range. Okay, and then your next bullet point here says that g of x is a reflection of f of x over the line y equals x. And we were just talking about that. Here's my line y equals x. It's a reflection over that line. And then the x-axis is a horizontal asymptote for the g of x. Okay, we haven't brushed up on this yet. Your g of x, your exponential functions had an asymptote. Usually we do like a dotted line. It's something it gets really close to, but it didn't actually cross. It did not cross this and come down into the negatives, right? There was none of that blue stuff. None of those exponentials were down here. So this was it was my x-axis, right? My asymptote was on the x-axis. But if I swap my x's and y's, if I do an inverse, it's not the x-axis, it's now the y-axis that is the asymptote for my logarithmic function. So this guy did not pass the y-axis. Again, I swapped my x's and y's. Same deal here. X-axis was the asymptote, but I did the inverse. Instead of the x-axis, then the y-axis is the asymptote for my logarithm. Okay. All right, any questions on these bullet points for your graph? We're gonna start applying that in a sec, but questions on this stuff? All right. Okay, let's see if we can apply it to this problem right here. They want us to graph this log base 3 of x. So we're going to plug in some x's here, and we're going to get the y's that go with it. Question though, do you guys know how to do log base 3 of x in your calculator?
You use the natural log.
Oh, so you have a natural log button. Do you have a button where you can enter whatever base you want? So does anybody have a button like, do you have something that looks like log and then you can enter whatever base and argument? Do you guys have buttons like that? Or is it more like, like this kind of log button and ln natural log button? All right, so Jack, you've got this one, and yeah, you wouldn't put an X in, but you do have this left kind of button that I'm talking about where you can enter the base and the argument. Does anybody just have these options? The log and the ln? You have those? Just those ones and nothing else? Okay, yeah. It's pretty common for scientific calculators. A lot of the graphing calculators, you can do more of this, enter the base and the argument. But I think, nice, okay, so Alani, Bailey, Ali, you guys just have these options right here, just the log and the ln. Oh, okay.
I'm not sure.
I think that one's a bit older, that's probably why. Yeah, you're gonna plug numbers in for your X. But I need to figure out how you're gonna enter this in the calculator. So let's mess with the calculators for a sec here. If you have this kind of button, if you can enter the base and the argument, great. I could put in my calculator like log base 3 of 2 in my calculator and I can get this y value here. But if you don't have that kind of button where you can enter the base and the argument, you might have to do this guy right here, change of base formula. If you need to jot this down, go for it. You can change this base into whatever base you have in your calculator. Like you can change it into a log base 10, this guy. You can change it into log base E, like your natural log. You can change it into a base that you actually could put in your calculator. So if you need to jot this down, go for it. Let's actually use it for a sec here. We were talking about doing a log base 3 of 2 if you can. If you can't do a log base 3 of 2 though, I'm gonna do this formula. The log base 3 of 2, like my b is a 3 and my x is a 2. So in this other one, I can choose whatever a I want. I'm gonna turn this into, maybe I'll do like ln, natural log, sure. I just chose one of the ones I actually have on my calculator. So I'll do the natural log of 2 over the natural log of 3. All right, you guys at home, take a look at your calculator, see which method you can use. Are you gonna enter the black one or are you gonna enter the purple one in your calculator? Okay, so I'm going to show you this one. I'm going to enter it both ways. For me, like I said, I have a graphing calculator. It's a little newer. I have this log base option here. I can do log base 3 of 2. And here's what I got. Or if you guys have scientific calculators, there should be, like I have an ln button. My natural log of 2 divided by my natural log of 3. So I'm doing like that purple fraction there. And okay, I got the same answer, same thing. Doesn't matter how you enter it in. There's actually, I could do it with a common log if I even wanted to. I can do the common log of 2 over the common log of 3. And same answer. So there's multiple ways for you to enter this in your calculator. Look at whatever it is you're going to use on the test and let's figure out how to use it. Okay, anybody having a hard time with their calculator? I wish I could walk around and look at them, but.
Will you just show me or us how you did the log on your calculator again?
So
You could enter
like
both
where
of
I can
them.
enter whatever base.
3,
Okay.
base 2.
So I went to the math menu on the left side here. And I pushed my up arrow. It took me to this option here, log base. So I chose on that one. And then I can enter whatever base and argument I want. Yeah. Yeah.
That's easy, thank you.
Yep. All right. So yeah, Jack, you tried. Okay. So I just tried with a positive 2 and I got this messy 0.6309, yada, yada. I'll probably round it to a 0.6 here. But Jack, you were doing like the -2? Is that what you're doing? The -2 and the -1? Yeah, and those are like giving you some error. So let's see, in my calculator, is that what I get? So I'm doing log base 3 of a -2. Oh, error as well. Mine says error, non-real answer.
Yeah, it gives me undefined.
Undefined also, yes. It's because this gives me like some imaginary number, whatever. I'm not going to graph an imaginary number on my graph. I can only graph real numbers on my graph. Which, okay, think about this. This is a negative x value, right? And on my logarithms, the red graph here, I didn't have any part of that logarithm and any part of that red curve was on the left. I didn't have any negative x's. So that kind of makes sense why if I plug in that -2, it's like error. Like I don't have anything I can put on the graph there. Same thing with the -1. I got like error.
And 0.
And the 0 as well.
Yeah.
The 0 is where the asymptote was. That's why there's undefined on that one. I've got to put at the x value of 0, so like on my y-axis, I have this asymptote that it gets really close to, but it doesn't actually hit it. So that's why that was also undefined. Whew. So far, I only have a single point that I can put on there. Let's try the positive 1 here. Oh, that gives you straight up 0? Nice pretty whole number. All right, let's plot these points. I've got the point 1, 0. And I've got the point 2.6, like a little over a half here. All right, I only have a couple of points. It's definitely not a straight line because I can't go through that asymptote. I'm going to go off of this basic shape right here. I'm going to use this shape to curve and not cross the asymptote. So I'm going to use it curving through those points that I had. Ooh. Really close, but not crossing the asymptote. All right, so there we go. Do I have any questions on this before we try our last graph? So I can't say always, Jack. There are different transformations. Like if I shifted this whole graph to the left by 3, then yeah, I could put it would be over here and I could put a couple negative numbers in. That's true. So I can't really say no negative numbers will ever work. Different transformations can adjust that. That's just why these ones did not. All right, good question. Anything else? Seriously, calculators. Do you guys know how to use your calculators and get these answers? You guys at home? I want to make sure you use your calculator here. So like, let's see. Wilson, you're at home, right? Wilson, I'll have you use your calculator for the 2. So you sub in the 2. And then Aaron, you're at home as well, right? Aaron, I'll have you sub in the 1. Can you guys get back to me, Wilson, Aaron? Just so I know you're there. Wilson, you're there. Awesome. So Wilson's going to plug in the 2. Aaron, are you there? Aaron's not there. Oh yeah, Aaron, you are there. Okay, awesome. So Aaron, you plug in the positive 1. And then Sam, I want you to plug in the 0. Samantha, will you plug in the 0? Let me know what you get. Nice. And it is a log base 1/2 this time. So use those calculators. Just type it up, you guys. Whenever you get it, just type it up. Let me know what you got. And you got straight up 0. Okay, so you plugged in your 1 and you got out a 0. Okay, got the 0.10. Kind of makes sense. I got the same thing over here. So I think, Wilson, I think yours is going to be kind of a messy decimal. Okay, so you went to a negative 0.6. Okay. And then, let's see, oops. And then Sam, what'd you get for plugging in the 0? Yours said error. Okay, so it's going to be kind of like what I saw over here. I kind of crossed that out. Yeah, it doesn't work exactly. All right, so let's check this one out. So Wilson, you got, hold up, you got a negative 0.6. I just did my log base 1/2 of 2 and I got a negative 1. So we both got a negative, but I got a negative 1, you got a negative 0.6. So Wilson, were you using like the change of base formula, like the natural log or the common log, that kind of thing? Or were you entering a base 1/2? And Sam, you're right, that's out. In fact, all those guys are out. Okay, so which way are you entering it? Are you doing it like this, log base 1/2, or are you doing like this change of base formula? Which one are you doing? Oh, for the 1/2. Okay, so maybe adjust that. Let me know what you get here. If anybody's using the change of base formula, I didn't have to use a change of base on this particular calculator, but I know a lot of the calculators do. So if you did the change of base formula, I would change it to either a natural log or a common log. And that also ended up with a negative 1. Okay. Nice, you got the negative 1 now. Okay, so I got the point 2, -1, which is right there. And, okay, let's clarify real quick. This is a log base 1/2, right? Which isn't a half between 0 and 1. So my base is between 0 and 1. I'm in this category. My log will look kind of like this. It still has an asymptote as the y-axis, so it gets really close to the y-axis. Just up top, it gets close to the y-axis. All right, so asymptote right here. There's my y-axis. I'm gonna get really close to it, but not cross it. Okay, so whew, super close. Curves away. Okay. So that's my log base 1/2 of x. It's got a base between 0 and 1, so it's that like exponential, or sorry, it's that logarithmic with base between 0 and 1. Do I have any questions on this kind of thing?
This is probably a dumb question, but where did you get the asymptote of 0 from?
All right,
Just
so
like-
I got that. So the x-axis is the horizontal asymptote for my g of x, like so for my exponential functions.
Uh-huh.
And then the y-axis is a vertical asymptote for my f of x, so like my
Oh.
logarithmic. Like-
Gotcha.
So like both of these red ones, these red were the log graphs, and they both had an asymptote of your y-axis. It did not cross the y-axis. All right. Anything else? What else we got? No? All right.